Hi, hello. My name is Marcelino Gutierrez. Welcome to the CIER-MMI 2022. I'm happy to be here and thanks for the invitation. We're going to talk about a control system for automation of a didactic test bench water canal, which has the objective to update an old system that we already have in our university. I hope you like it. Well, in a water canal didactic test bench, students can analyze and can verify some phenomena like sediment tracks, waves, even they can check water flow through the canal. For example, in this case, as you can see in this picture, we have to understand that a water canal it's formed by a part that is called the transport zone and the storage zone, where students can notice the different or can notice when the drugs are being moved from one side to another side. And when you have the base and you have the height, obviously you can use it to calculate the water flow going through the water channel. And in this form, well, students can reinforce their knowledge about hydraulics and hydrodynamics, etc. To say some classes that they have in civil engineering, which is important for them. As I mentioned before, hydraulic phenomena, it's important for students to know, for example, sediment drags, because in this form they can observe how the erosion can affect and compromise the security of the fundamentals of bridges, and it's important for them to notice and see it, obviously. And besides, for example, in a water canal, they can check the water flow going through the canal and calculate it in order to know exactly, or to have an estimation of water consumption and water demand, for in this case for watering plants, watering the growing fields, and for example water consumption in big cities, or waves. For example, waves is important to have an idea how waves are modifying the sand or the basic form of the soil, in this case, where, for example, constructions can take place. Okay, you can see in this picture a basic configuration for a didactic basic water canal, which is formed by a canal framing, a canal base, the canal, in this case, a water tank, a water deposit, and a lifting shaft. For example, the water that comes from the water tank and goes through the canal, and at the end it ends up in the water deposit. There is like a closed water circuit that it's recirculating the water through a water pump, in this case, and students can be calculating the water flow that is going to go through the canal. But in this case, for example, in order to increase the speed of water or to have a slope in the channel, we have to use a manual mechanism that it's, like I said, the lifting shaft. It has a mechanism which you have to turn it around to lift it up or put it down. But it's manually, you have to see the slope, you have to calculate it, which is not very suitable for some classes. No, I mean, the idea is to have an application, to have a system that can do this automatically instead of doing manually. Okay, in the two pictures on the left, you can see this mechanism, and you can see how you have to turn it by hand, and you can see the slope. In this case, is well, it's calculated like in percentage, and we have to calculate like 1%, 2%, 3%, and then we have to start turn it until it goes up, and then well, you have the slope that you require. The idea, basically the idea is to have an electronic and automatic system which is capable of lifting the water canal in a position which is going to be determined by an application in a mobile device without having to do it by hand. Now in this case you have to select the slope you want, and this application has some other advantages, like for example it can calculate the water flow through the channel because it has a sensor connected in the base. Well, there is a hose connected from remember the water tank and the water deposit. So instead of just the students calculating the water flow, now we can measure it with a water flow sensor that is incorporated. The parts that conform this system are AC-DC converter and at the same time controller for the DC motor. It's a brushed DC motor, and well, the idea to use a brushed DC motor is because it's cheap, and since the work that we're gonna have or the students are gonna have with this system is not too much. For example, BLDC motor is not necessary, which is more expensive. But this motor is enough to work to operate the system. And then this motor is connected to a system of, well, a set of relays which are gonna indicate when it's gonna start and gonna turn off, and it's gonna turn in one direction or in another direction to start lifting the shaft or putting down the level of the canal. And we're using an ESP12 board to have the wireless connection, and is the main board that controls the whole system. It has a communication with the application, and as you can see in this picture too, there is the accelerometer or gyroscope in this case, because it's the one that we're using to estimate or determine the position of the water canal, and the water flow meter that is necessary in order to know the water flow that has been going through the water channel. Now you can see the app, one that is in charge of controlling the system. It has some buttons. For example, it has one for connection, and once the app is connected from the mobile device to the system, to the board that I already mentioned, by means of Bluetooth, we have to use this button that says connect in order to establish a connection. And obviously the same thing for the button that says disconnect, and then we have another button that says reset and save to cloud. Reset, basically what it does is that it restarts the counting of water, and set to cloud sets the information to a web server in order to be saving the water consumption or the water going through the system. And there's another button that it says set. In this case, set is like to start the counting, to start the water counting. When the system starts, we want to make sure that the water, when we get to steady functioning, we want to make sure that we are counting the amount of water that goes to the canal exactly, without measuring the first amounts of water, which can be not very precise. Now with this button we can start like recounting, and make sure that we know exactly the amount of water that is going through the water canal. And it says it has some displays. It has the part that it says liters by seconds, liters by minutes, or the time that has gone through during the test, because some tests can take, for example, more than minutes, more than an hour. Probably it can be on for almost a day, some days, and well, these are some advantages of the system that it has. These are the stages of the update implemented on the old and basic configuration water canal. For example, you can see the DC motor. It's a 90 volts DC motor, and the water tank, where is the heatoscope connected in order to measure the slope or inclination for the water tank and the channel, the water canal. And we have the flow meter that is connected by the hose in order to measure the water, and we have the relay sets to start the motor, and inside that box we placed the controller for the DC motor. The contribution for this work is not only in the system making, but it's also in the application design, communication, and the web system program that was implemented in order to have the system working. And it was a collaboration from people from the University of Guanajuato and people from the University of Querétaro here in Mexico. And we're happy to collaborate together, and well, basically that's a project that came out from the idea of this group of co-workers. I hope you enjoy it, and I hope it's helpful for you. Feel free to contact us in order to tell you and help you if you consider this interesting for you. Thank you. Well, the results that we had basically are, for example, slow position control has an accuracy of 98% compared to the plastic scaled and the manual system that we have to have, because when students do it, they trust in the lecture that they see, and well, even though this scale it's graduated, but it's not very precise. With the gyroscope, you can guarantee the slope that you give to the water canal. So, and we measure it with two different gyroscopes, one with the one that is in the system and another one that we have in another work that we have done before, and it is the same value. So there are just some decimals that we have to consider. That's why, in order to calculate the error for this position estimation, we consider, or we get a 90% of accuracy. And the water flow measurement helps to corroborate the water flow estimated by students at the moment they have the practice, and students can compare it. And the water flow can be saved even per weeks or months or hours or the time that it's necessary, because of the cloud system, the cloud server that we have, in order to have long-term tests. The system is it's a good alternative. It's a good alternative for projects where budget can be difficult for an education institution, and it's not easy to obtain expensive systems to give students the chance to practice. And well, this system proved that the slope can easily be selected and can be estimated or calculated with the system that we implemented. And the main board can be replaced for a bigger one or a faster processor in order to update or have more versatility, more sensors can be connected. So depending on the necessities of teacher student, this system can be updated, can improve. And probably for future work, the idea is to control the water flow going through the canal by controlling the water pump in order to control its speed and make it go faster or make it go slow. So we found this project very challenging and very interesting for our students, for ourselves, so I hope it is helpful for you. And finally, we want to thank again to University of Guanajuato and University of Querétaro for the support that they gave us for this work. Thank you very much.